Hello again. So we'll move to the next part of the project, which is thinking through what the borrower state should look like. Now, I've already have a lender state. So the borrower state should look something like, we should have a mapping. So yeah, I should probably mention before I do this, that a borrower can deposit a multitude of assets. A lender can only deposit one asset, so a borrower can deposit a multitude of assets. So we need to know what the asset is, okay? And a borrower can only take out a loan per asset. All right. So let's try something. So let's say mapping. Let's do user address. So just so that I find this to be helpful for some people. I think if it's wrong, I'll fix it. So we're gonna have a nested mapping. Okay, let me take this out. So let's call this borrower address, and the mapping is address. This is collateral asset address to amount, okay? Public. Borrower's asset. So here we have amount. Yeah, so I had to write all this mapping here, because if I just say address, you're not going to know how this is different from this, okay? So it's helpful sometimes to write this thing in there. You probably see where I'm going with this. I can do another borrower collateral this, borrower collateral that. We end up with what we ended up before. So let's think through what the structure look like, okay? So let's say borrower account, okay? Let's look at some things that it should have, okay? And it's not just borrower account, there's also a loan. There's going to be one for a loan as well, but let's address borrower first. So the first thing is we should have, so within our borrower account, we can actually make it interesting in the sense that we can move this mapping into our borrower account. So that this becomes borrower account, okay? Internal or recursive type not allowed. I'm going to see what it means for that. Good. Oh, sorry. So let's call this let's call this borrower info, borrower. Actually, let's call this borrower info. Let's call this borrower assets. Okay. What is the problem? Quick fix. What's the problem here? Use the entire context. Ugh. Yeah, no use. So it's saying that I have a problem here. What could be the problem? You know what? Let me do something. You're in 256. Let's have amount. I think I understand what might be wrong. It's the mapping format that is wrong. Oh, apparently you can't have only a mapping. npx had that compile and check something. You can't have only a mapping within a mapping, there has to be other fields. This is, wow, Solidity needs to fix this. This is terrible error messaging. This tells me nothing. But anyway, yeah, we've seen now that, so we have a mapping within a mapping, all right, borrower account. But apart from that, let's have something called an active loan count, maybe. Actually, no, active loan count doesn't make sense, because if it gets liquidated, it's maybe. You know what? Let's leave it out for now. In the future, I can think about adding active loan count and liquidated loan count, and then we can use a combination of it to estimate a borrower's credit worthiness. You know, how credit worthy it is. Should I add it now? You know what? I'm gonna add it. I'm gonna add it so I don't forget. Okay. So let me add something called active loan count. I'm going to add something called UN256 liquidated loan count. Now, obviously, I don't need this. I might not even use this throughout the course, but I'm adding it so that I know that I can always come back to it and use it when I need to. Okay. Now, what else do we want to know? We know the assets that a user has borrowed. Let's come to okay, so for when a user deposits collateral, it goes in here and this goes up. When a user repays loan, this goes down. Okay, so this seems to be the only field that I am aware of. Okay, yeah, so this seems to be the only thing. To be honest, we could potentially leave it the way it was before. You know, we could have left it with the nested mapping format, but I think it's cleaner this way. I also think that because we also have these two and potentially more stuff that could come in, I think we should leave it. You know, I think it's good. So we've kind of mentally handled this. Let me check something. Do I need any other info? Let me see. Borrow. The next thing that I want to potentially look at is the loan. Let's treat loan as well, okay? Which is loan ID, okay? Obviously, lender state, borrower state, global state. So the loan ID is part of the global state. So let's come here. Let's do a mapping of a bytes32, which is an ID, to something called a loan. And we'll have public and we'll call those loans. Obviously, loan doesn't exist, so we create loan. So what do you think the loan should be? Loan should have struct loan. Obviously, I sometimes like to store a copy of this within the loan itself, but some people say it's a waste of space. So maybe we don't store it for now. But what are the things that we need to know when a loan is taken out? One, let's know what is the collateral. So the address, collateral, token, address. Very important. The next thing, oh yeah, there is something that we also need to know. We need to know the price feeds, but that's a different mapping. I'm going to come to that. So let me see. Or should I take in the price feed ID? Oh yeah, it makes sense. Let's do bytes32 price feed ID. So this is the what you're taking the collateral against. This is the Pyth. This is the price. This is the Oracle ID. Oracle ID. For before we integrate the Oracle, this is always going to be like an empty slot, you know. So another thing we need to know is we need to know the liquidation price. So UINT 256 liquidation price. Another thing we need to know is we need to know amount borrowed. Okay, and then there's something I left out here. UINT 256. This needs to be collateral amount deposited. Why is this important? This if you look here, a deposit, a borrower may, you know, put like $1,000, but they may only be willing to take out loan for like $1,000 worth of assets, but they may only be willing to take out loans for like $500 worth of assets. Okay, so we need to estimate that, you know, the quantity times the price of this asset is actually within what we want to obtain. Now, just thinking about the price and quantity here, it tells me that I need a function. I need a function here to estimate, calculate price times quantity. Calculate price times quantity. Let it be explicit as possible. UINT 256 price, UINT 256 quantity. Okay, and then this is going to be internal view returns, and then it returns UINT 256. So maybe, okay, so maybe a person deposits 10 Bitcoin. When you do price times quantity, it returns the value. Now, this price times quantity would be important when you want to borrow. So when you want to borrow, I just clicked that, we didn't write borrow. So add a function here, borrow. When you want to borrow, you need UINT 256 amount. You also need to specify what you are borrowing against. Okay, amounts. So you're borrowing against collateral token address. That way you're not borrowing against your entire portfolio, you're borrowing against a specific asset. Now, we've added borrow here, we've added this. This makes me realize that this borrower asset, so when a person calls borrow, the value of this goes down. Yeah, collateral asset. Yeah, that makes sense. That makes sense. And when a person repays, the value of this goes back up. That makes sense. Okay, boom. So we've added one more function to our this, one more this. Okay, so amount borrowed, obviously, you know. Liquidation threshold, this is global loan to value, this is global. What else do we need to know? We need to know the interest rate at which it was borrowed. So this is tricky. it's either the interest rate is fixed or the interest rate is variable. If the interest rate is fixed, then it makes no sense to store the interest rate here. But if in the future we might make the interest rate variable, then it makes sense to store it here because a person's interest rate that they borrowed at a loan at can differ from loan to loan. Okay, so I am going to go out on a limb here and do. So there's also the possibility of saying interest rate can be global for everything, or you can say, oh, the interest rate for this asset is this, the interest rate for this asset is that. So if you're going to borrow a risky asset, I'm going to charge you more interest rates. If you're going to borrow, weak asset. So what we're assuming is all the assets within this pool, they all have the same interest rate, right? But depending on the amount of money within the pool, the interest rate can maybe move up or move down. We may if there is enough time, we may be able to make that dynamic interest rate within this. But if there isn't, then we will leave it out. So I'm going to say here 256 public. Let's add interest rate per second, okay? And let's call it base interest rate per second, just in case we decide to add another quantity to vary it, okay? Let's write a setter for it as well. Function set base interest rate per second, which is a UN 256 base interest rates per second. Here we go. So yeah, we have that sorted. Based on that, we then want to know what is the interest rate that applies to this loan, so that when the repayment is being calculated, we know what it is. Okay, so this is now interest rate for loan. Okay, so we have collateral token address, collateral token amount deposited. So this amount and the price that we get it at gives us the liquidation price. So maybe this amount is 500 and and then the price of the asset is maybe $100. So we know, okay, if the liquidation threshold is 80%, or if the liquidation threshold is 50%, let's just say it will probably not be 50%. So we have 500 times, say, 100, that is 50,000. So the liquidation price will be 25. Will be when the price hits 50. So when the 100 becomes 50. So actually, this liquidation price, it seems like we're going to be basing the loan amount based on, yeah, this is going to be used by something else, I think. I mean, I'm not sure if I need this function, to be honest, but let's leave it there. If we don't use it, we can always remove it. Yeah, so because the liquidation price, once you have the threshold, you can always calculate the liquidation price. Yeah, so that's that for that. The amount that you borrowed, I said we're not going to support partial loan repayments. Because I don't want to make this too complicated. I am going to add it in the future. So what I'm going to do is I'm going to say UN 256 amount repaid. Okay, and I'm going to comment it out. I'm going to add it in the future. Okay, so this interest for loan. Then we also Each loan has a state. A loan is either active, repaid, or liquidated. So we need something to track that state. Loan state. So a loan is either active, repaid, or liquidated. We need to know. Actually, there is a fourth state. Inactive. All loans are, before you take a loan, this is the default state. It's going to be inactive. But unfortunately, I don't think you can set a default state. Think about this very carefully. Enums are important when you are able to set a default. If you use an enum, it exists in 3 of these states at the same time. So will a loan ever be inactive? No. A loan is either active, repaid, or liquidated. A loan is never inactive because if you've not borrowed, there is no loan. So this doesn't make sense. So this is fine. So we just created an enum. An enum is a data type, a custom data type. So we call loan state here, and then we say current state. Some people say current status. Okay. Yeah. For the repayment, yeah. So a loan, you have a loan ID, and the loan ID maps to a loan, and the loan has a collateral token address, which obviously you're collateralizing against. It has the amount of the token, so this would be the full amount that it would take. So this is the full amount that supports the loan. So when the loan gets liquidated, this is the amount that gets sold off. When the loan gets repaid, this is the amount that gets repaid, that gets restored. This is the price feed ID. This is where what we'll be using to estimate if the loan is viable or not. I am going to write a function called estimate health factor. So function is estimate loan health. This is going to obviously take in a loan ID. And it's going to be external, so everybody can call it view, and it's going to return a boolean. Actually, it's going to return should it return a boolean or should it return, for now, let's call it can be liquidated. Okay, and it's going to return a boolean. All right, boom. All right, can be liquidated. Okay. There is an internal function component to this, but I would think through it. This is a lot of functions already, and we're going to be adding more to it. Yeah. So we have this lender accounts, pending rewards. I think I have to store the accrual balance actually, but we'll confirm that anyway. This is messy. I don't like messy. move it to the bottom. Okay, good. All right. Yeah. So I think we have defined most of the things that we need to start writing our function. Yeah, we have. So in the next week, we will begin writing our function. But I should probably point out that for you, it will be next week. For me, it will be this week because I'll be making these videos and releasing them. So the next sets of videos will start fleshing out everything we've written here. Now, obviously, my tests pass. There's nothing to test here. Here we're just defining what we spelled out here. I said design interfaces and implement interfaces. So specify input and output parameters. And I should also have said here, define storage state. But technically it's a part of this anyway. So we've defined, this fleshes out the shape of our contract, when a loan is active, here's active. When it's repaid, it's repaid. When it's liquidated, it's liquidated. And, we're going to have it in record. We're not going to delete the data. We're just going to have it, so people can say, oh yeah, I lost this loan. Yeah. So this is everything that we need to start. Okay. So happy coding. See you on the next set of videos.